Welcome back to easy concept. In the case of circular arches, the following equations may be used. Okay, so the equation for circular arches, so we can do this. So this is the circular arch. Okay, so equation for circular arch. Let us consider a circular arch. So this is the circular arch. Okay, and this is the center point. This is the center point. That is YC. Okay, this is centroid or center of the circle. Now this is the radius at any section. This is the radius at any section R. Okay, now see here the distance x is measured always from the center of the circle. This is x. Okay, this is x, and at any distance x, the rise is measured as y. Okay, now our aim is to find out the relationship between y, x, yc, this r. Okay, now what we can do, this is the length divided by 2, and this also length divided by 2. Okay, now we can write a relation. Let me take this point is D, this point is C, and this point is F. Okay, now this point we can call it as this is O. Now in this right angle triangle D F O, we know that D O square, which is equal to D F square plus O F square, right? In this right angle triangle, D O square is equal to D F square plus F O square, right? Now D O square we can write is radius R square, which is equal to what is a DF? X square plus what is OF? OF is equal to, we can write total R from here to here is R minus, if you subtract this YC plus, actually OF means only you need to subtract this amount. This amount can be subtracted by doing the process of R minus YC, then you will get up to here plus this Y. Okay, so Y, so that you will get answer. Okay, the whole square. Okay, so now R square is equal to X square plus R minus YC plus Y the whole square. Therefore answer for this question we understood this. And one more formula we can write from the property of circle. From the property of circle we can write one more relation, that is 2R minus YC into YC, which is equal to L by 2 the whole square. Okay, for example, this is the circle, this is the point YC, and the remaining is what now? 2R minus YC, 2R minus YC. Okay, and this is L by 2, this is L by 2. Now L by 2 into L by 2, which is equal to 2R minus YC into product. Okay, so that means product of this length and this length is equal to product of this side and this side. Okay, so this also property of circle. So to analyze this kind of arches, we will use these two property so that we can able to find out the answer. Okay, so it's very important, keep this in your mind. Next one, the fixed end moment at the left support of a beam subjected to uniformly varying load of intensity Q at the left end and zero intensity at the right end is given by. So before that, let me give some of the formula about the fixed end moment so that you won't confuse. So let me give the formulas. Okay. Types of beams. First one is simply fixed beam with a point load. This point is A, B, center point load, P, or W. We can take it as a W. And fixed end moment for AB, fixed end moment for BA. What is this? This is minus WL by 8, since this is the anti-clockwise, and this is the clockwise. So this is WL by 8. Clockwise is positive. Next is simply supported beam with a UDL acting throughout the span, that is W, minus WL square divided by 12. This is plus WL square divided by 12. This is second one. Third one, fixed beam with a eccentric point load W. This is A and this is B. Minus WAB square divided by L square. WA square B by L square. So this is the answer. Now, fixed beam with a couple. Suppose there is a couple M which is acting. Then in this case, this is a special case. If you apply a clockwise couple, then the moment also develops a clockwise direction. That means plus M by 4 and plus M by 4. The next one is if there is a UVL acting throughout the span, UVL acting throughout the span. Suppose this end 0 and this end is maximum. This end is maximum. This is the UVL. Then where the zero loading position, your value is minus WL square divided by 30. Where the higher intensity end, the value is WL square divided by 20. Suppose if the loading diagram is something like that. The loading diagram is something like that, then your intensity of moment at this left end is WL square divided by 20. How? Because the intensity is maximum at this end. This is WL square divided by 30. So this is the answer. So answer for this question is minus. A is the correct answer. Are you okay? Now we can move further. The degree of redundancy of a structure is shown below. So here let me give some idea about this degree of redundancy. Degree of static indeterminacy. That is first one for beam. For beam, the degree of static indeterminacy, ds is equal to number of unknowns minus number of equations available minus number of additional equations due to hybrid joints. Okay, due to hybrid joints. So we can write this ds is equal to now number of unknowns. We can take it as let us take number of unknowns equal to capital R. Number of equations available, generally 3, minus number of equations available. If you want, we can take it as x. Number of additional equation is small r. Okay, so which is equal to r is equal to, in this case, how many reactions are there? Here 3, here 1, here 1, total 5. What is a x? X equal to 3 for 2D structure, and minus, there is no hybrid join, therefore this is 0. So answer for this question is 2. Answer for this question is 2. Okay, so this is the answer. Now, what is the concept of the hybrid joint? R is the number of additional equations for hybrid joint. R is equal to what? So that we are going to see this R is equal to, for a shear hinge. This hinge is called a shear hinge. If you use a shear hinge, then this value is equal to 1. Okay, what is R? If we use a moment hinge, this is the moment hinge. Moment hinge, then this value is n minus 1. What is n? Number of members connected on that hinge. Okay. Now, if there is a link, this is called as link. This is link. For link, number of additional equation due to hybrid joint is 2. Okay. Now, this is the answer. So here now, what about x? X is the equations. 3 for, that is the number of equations available. Okay. Number of equations available. Number of equation in the sense equilibrium equations. Equilibrium equations are available. 3 for 2D structure and 6 for 3D structure. Okay. Let me give one example. Suppose you are having a beam. The same beam I am going to take. This is a roller support. This is also a roller support. There was a hinge. This is the moment hinge. Moment hinge. Now the degree of static indeterminacy is equal to, here number of unknowns 3, here 1 4, here 1 5. Number of unknowns 5. Minus x, number of equations available 3. Minus, here there was a hybrid joint. This is the moment hinge, therefore you have to take it as n minus 1. So this is 5 minus 3. What is a n? Number of members meeting at that hinge. 1, 2 members are meeting. 2 minus 1. Therefore, answer for this question is 1. That is a static indeterminacy. Okay. Now next. So next question is this. The equation of finding inference line diagram ordinate for reaction at the propped end of a propped cantilever beam. So this is the question. Now see, we are going to solve this question where n is equal to x by L they give. Okay. So for example, we are going to draw ILD for propped cantilever. So this is the propped cantilever. What is the ILD? How to calculate ILD? So this ILD for RA, they are asking ordinate for reaction at propped end, right? Therefore, this is the prop reaction. In order to draw ILD of this prop reaction, remove this prop end, that is, remove this reaction and apply one unit deformation in the direction of reaction and draw the displacement curve. So, remove this reaction and apply one unit deformation. Once you apply one unit deformation, then you know how the deflector shape looks. The deflector shape looks something like that. This is the deflector shape. This deflector shape is qualitative and this ordinate is 1. This is something like that curve. Okay. Now, this ordinate is what? This ordinate is what? This ordinate. Now, we need to calculate this ordinate. That means this curve follows a equation. Once you understand the equation of this ordinate, this curve, then we can calculate the ordinate of each and every ordinate of this ILD. Okay, therefore you have to find the equation of curve. Okay, equation of curve is what? Equation of curve is what? For calculating this equation, what we can do? Calculation of this ordinate, what we can do? We can do this procedure in the indirect way. Meaning, you have to apply 1 unit force in the upward direction and find out the displacement. Well, this is the displacement curve, right? Apply 1 unit force and find out the displacement. Okay, for that, what we can do? Take moment about any section. Okay, take moment about any section. Now, moment at x is equal to minus EI into d square y by dx square. So this is the moment at any section. Okay. Now we can write this EI into d square y by dx square, which is equal to, we can write what is the force into distance, moment. Force into distance equal to x, right? X. So there was a minus symbol. So this is the general formula. So substitute that minus symbol. So EI into d square y by dx square is equal to minus x. So this is the formula. Now you have to differentiate this with respect to, not differentiate, integrate. Integrate with respect to x. Therefore, you will get a slope di into dy by dx, which is equal to minus x square divided by 2 plus constant of integration. Again, you have to integrate it. EI into y is equal to minus x cube divided by 6 plus c1x plus c2. So this is the answer. Now we need to calculate the deflection curve, right? Deflection equation. There are 2 constants. You have to first of all calculate the constant. We know that when x equal to L, y is equal to 0 and dy by dx equal to 0, that is a boundary condition. When you extend this x is equal to L, then slope at this point and displacement at this point is equal to 0. Okay, therefore this is equation number 1. Equation number 2. Equation number 1 implies if you substitute x equal to L, dy by dx equal to 0, then this becomes 0. C1 is equal to x square divided by 2. Okay, C1 is equal to x square divided by 2. Similarly, equation 2 implies this is 0. So you will get 0, which is equal to minus x cube divided by 6 plus what is a C1, x square divided by 2 into x plus C2. Therefore, C2, which is equal to, okay, here also x equal to L, right? Therefore, this is equal to L. X equal to L and this also L. This is L cube. Okay, this is L cube and C1 is equal to x square divided by 2 L into C2. Therefore, we can write C2 is equal to minus L cube divided by 6. This x equal to L. So L square into L divided by 2. Okay. Actually, this is plus and this is minus. So answer for this is 6 is the LCM. Okay. So this is L cube minus 3 L cube. So answer is equal to minus L cube divided by 3. This is C2. Now if you substitute C1, C2 in the equation 2, substitute here EI into Y, which is equal to minus x cube divided by 6 plus what is the C1? X squared divided by 2 into x minus L cube divided by 3. Now this is the final equation. Now see this equation not satisfy any of the option that I have checked. Okay. So EI into Y square, this is the deflection ordinate. And if you want, you can substitute N is equal to X by L. Okay. Here N is equal to X by L. We can't rearrange this by substituting N is equal to X by L in order to get the option. You can try if you want. It is very difficult to get it. Okay. I think I personally felt it's not possible to calculate. And moreover, this kind of question is not fair for a TRB. Meaning, this question takes so much time. So these things take care of the question setter. That means the question setter should understand the nature of this TRB examination. They simply taken without knowing what kind of this exam, the TRB, without knowing they have taken. So this kind of question is okay for IES or GATE. Their nature is different, but TRB nature is different. Okay, and moreover, they given the option in wrong manner. Okay, the option also not fair enough. Okay, so as per me, this question answer is difficult to answer. Okay, so better in your examination, you have to mark any one of the option. If they felt this question is wrong by a question setter, then definitely they will give the mark. Okay, but this is the procedure. So this is the procedure to draw or to calculate the ordinate of the ILD for indeterminate structure. Okay, note I can write for determinate structure ILD is linear, whereas indeterminate structure ILD is non-linear, whereas indeterminate structure ILD is non-linear. Okay, so this is also important for your examination perspective. Okay, now we can move for the next question. A simply supported beam of rectangular in section, it carries a uniformly distributed load over the whole span. There was a simply supported beam which is subjected to a UDL acting throughout the span. The deflection at the center Y is measured. If the depth of the beam is doubled, then the deflection at the center will be. So initial deflection is Y. So for this case, the deflection of beam is Y. And in this, the cross section is B. This is D. In another case, the cross section is doubled. The depth is doubled 2D. This is B. We know that the deflection is equal to 5 by simply supported beam 384 WL power 4 divided by EA. So this is the formula. From that you can write W is directly proportional to the same load is acting in the second case, length of the beam is same, material also same. Therefore 1 divided by moment of inertia. So we know that now y1 by y2, which is equal to I2 by I1. Y1 by y2 is equal to, what is I2? B d cube divided by 12 divided by B d cube divided by 12. If you cancel everything, then finally you will get this. What is a y1 they given? Y2, which is equal to, this is not a B, 2D. So you will get 1 by 8. Okay. So the answer for this, sorry, not 1 by 8, 8. The answer for this question is y by 8 is equal to y2. So if you increase the depth, then the deflection will be reduced 1 by 8 time. So this is the answer. Therefore, answer for this question is D. Okay. Next one. A bolt is subjected to combined shear and tension. Will satisfy the following equation. So it's a very interesting. As per IES 800 2007 gave, if a bolt subjected to combined shear and tension, then it is satisfy the following condition. It is satisfy the following condition. What is the condition? TB divided by TDC, or we can B plus VSB divided by VDB, the whole square less than or is equal to 1.0, where TB comma VSB are the calculated tension and shear of bolt. Next one is TDB comma VDB are the tension and shear capacity. That is ultimate capacity, okay, or maximum limited capacity. Tension and shear capacity of bolt. So this is the interaction diagram, interaction equation. So you have to keep this in mind. Okay, it's a repeated examination question. Then most of the state government as well as central government examination, this equation. Okay, so be careful. The next one, the maximum effective slenderness ratio of member always under tension. Member always under tension is what? Other than pre-tensioned member. Okay, so answer for this question is 400. So let me give some of the values. Okay, the member subjected to pure tension, member subjected to pure tension, lambda slenderness ratio is equal to, we will take 400. Next one is member subjected to pure tension and, or we can write in the pure tension member pure tension member subjected to a reversal of stresses due to the action of wind and earthquake. Wind and earthquake. The answer for this question, lambda is equal to 350. Okay. Now the next one is pure tension member. Pure tension member subjected to reversal of stresses due to live load. Due to live load, the slenderness ratio is equal to 180. So these four values are important. This is for pure tension member, lambda is equal to 400. Now this is a pure tension member subjected to reversal load or a cyclic load due to action of wind and earthquake. This is a pure tension member subjected to reversal of stress due to live load. Okay, reversal stress due to live load, lambda is equal to 180. Reversal stress due to wind and earthquake, 350. Pure tension member, lambda is equal to 400. So this you have to keep in your mind. Okay, and for pure compression member, lambda, this also may be asked. For pure compression member, lambda is equal to 180. Okay, for pure compression member, the lambda we will take is equal to 180. For placing member, slenderness ratio lambda for lacing member, which is lambda is equal to 145. So this is also important. In the law 2012, the slenderness ratio of lacing member, I think that was asked. So this is the answer. Okay, so be careful. So these are the important point. So in the upcoming exam, you can expect it. Okay, next one. The thickness of batten shall be not less than. So the batten, thickness of batten, this is the column, single column. This is the another column. And these two columns are connected by using a batten to make a built-up column. So this is the batten. And here, so we will use the bolt. We will use a bolt or rivet or weld. Connect this. So we are having a bolt. Okay. These are the bolt. Now this S is calculated. This is the inner line of the bolt. Centroid of inner line of the bolt. This also centroid of inner line of the bolt. This distance we will call it as S. So T minimum thickness, okay, of batten shall be S divided by 50. This is the answer. So the answer for this question is this one. 1/50th of the distance between innermost connecting line of rivet or bolt or welds. Okay, so this is the innermost connecting bolt, centroid of innermost bolt distance. Okay, so this is the answer. I hope you got it. Okay, now next question, the economical depth D of the plate girder. So this is a factual question. MK divided by Fy, the whole part 1 by 3. Okay, this K is the radius of the gyration. MK divided by Fy, the whole part 1 by 3. Now, web crippling strength is calculated as, so it will be calculated, web crippling strength calculated as, see, in a plate girder, there was a bearing plate. Over that, we will apply a load B. And this is the plate girder. Let us consider this is the plate girder. Okay, this is a plate girder. The load distribution which it takes place in the ratio of 2.5:1. Okay, in the ratio of 2.5:1. So this is the load distribution. This is also a slope load distribution. This load distribution generally take 2.5:1, or we can say some constant is to 1. Okay, now we will consider the depth. The critical section is at a depth of 0.2 dW. What is a dW? dW is the width of the, depth of the plate girder. Depth of the web of the plate girder, dW. Okay. If we consider this as A, this as A or B, whatever may be B, then what is this distance? Now this distance, which is equal to, we can calculate the total, we can take it as alpha. This alpha is equal to this B plus, generally it is follows 2.5:1. Okay, so therefore this thickness, this one is 2.5 into 2.5 into this depth. Okay, 2.5 into, there are two axes. This is the depth wise, and in the thickness wise also we are having 2.5 is a depth and 1 is the thickness. Okay, so that's the thickness. Therefore you will get, this is T, 2.5 into T. So this side, this one is 2.5 into thickness of the plate, and this is 2.5 into thickness of the plate into 2. So generally we are having alpha is equal to B plus 2.5 T into 2. This is the total width of the plate. Okay, now what is a permissible stress? Permissible bearing stress, which is equal to, we can write total load P divided by this, P divided by alpha into thickness. Okay, alpha into thickness of the web. Okay, so therefore this is 0.2, which is equal to, I can take it as a T. Okay, for this T only we are taking 2.5 into this depth T. So now if you simplify this, P divided by What is the alpha? Alpha is equal to B plus 2.5 T into 2, T into 2, okay, into TW. So this is the permissive bearing stress. Now we can write what is the permissive bearing stress? FYW, we can take it as, or FY, simply take it as FY, or FYW, whatever may be. FYW into B plus 2.5 into T into 2 into TW divided by factor of safety. The factor of safety is equal to M naught. Permissible shear stress means what? There was a factor of safety. Therefore, you have to multiply here factor of safety also. So this is the strength. Now web crippling strength is equal to this. Okay. Now this is the actual formula. But here this formula is, this is the best option. The best option is A. In this option only, you are having yield stress divided by factor of safety. Yield stress divided by factor of safety. And there was a quantity. So this quantity, they simply gave the constant n, summation of these two, and plus the B is the width of the plate, B, and the thickness of the web. So we have to consider option A is correct. But in the question, they did not mention what is a B1, what is a N2, what is TW is generally we know, these things we know. But B1 plus N2, they didn't mention. But from this, we have to understand, okay, which this is the best option. B instead of B, they given B1. Instead of this entire quantity, 2.5 T into 2, they given N2. Okay, yeah, the bearing stress is calculated for this thickness. Thickness you understood, right? If you cut this and see in the top view, then you can able to see the thickness. Okay, okay, fine. So option A is correct. In the Nagpur road formula, we are prepared for assuming the shape of. So answer for this question, the Nagpur road formula is prepared for considering star and grid pattern. So this is the very interesting thing, factual data. Keep this in your mind. Okay. The equation for length of transition curve for plain and rolling terrain. So answer for this question is this one. See, length of transition curve is equal to 2.7 V square divided by R for plain and rolling terrain. And LS is equal to V square divided by R for mountainous terrain. For mountainous terrain. So the answer for this question is obviously C. Okay. Next one. The instantaneous speed of a vehicle at a specified location is called as instantaneous. Instantaneous speed of a vehicle at a specified location is called as spot speed. Okay. So we can write some more point about this spot speed and the speed study. So that the upcoming examination you can attend if the question is coming from speed study. So we know that the speed study, there are two speed study. One is spot speed, another one is average speed. The average speed further divided into two. One is time mean speed, another one is space mean speed. One is a time mean speed, another one is space mean speed. First of all, the spot speed. The spot speed is calculated by this. I will ask you the question. Measured by loop detector. Okay, loop detector. Next one is contact pressure tube. contact pressure tube, then ionoscope. Contact pressure tube and ionoscope. These all are the equipments that are used for measuring the spot speed study. So you have to read this. In the upcoming years, you can expect a question. Then what is a spot speed? Spot speed, it is the instantaneous speed, instantaneous speed of a vehicle in a particular location. In a particular location or section. Particular location or section at a instant of time. For example, there was a road stretch. Let us take a section XX. In this particular section, at a instant of time, what is the speed of a vehicle? That is a spot speed. Second one is average speed. Average speed further divided into two. One is a time mean speed. Time mean speed. You can expect a question in the upcoming years. Okay. Speed. Yes, they have been asked spot speed. The remaining speed is time mean speed and space mean speed. Maybe this year you can expect. Okay. The time mean speed means is the arithmetic mean of speed of all vehicles passing a point on a road over some interval of time. Meaning there was a stretch. Okay, in that there was a point. This is the point XX. In that n number of vehicles are passing. Okay, you have to calculate the speed of this n number of vehicles between a time interval, for example 10 a.m. to 12 p.m. You have to measure the speed of all vehicles for a certain interval time for this particular section, and which was measured VT, time mean speed, is calculated. Speed of first vehicle, speed of second vehicle, speed of third vehicle, etc. Speed of n vehicle, the whole divided by n. So this formula is important for your examination, where n is what? Number of vehicles. Second one is space mean speed. Space mean speed, it is the harmonic mean of harmonic average speed of all vehicles over a certain road length. Over some interval of time. So this is road stretch. In this case, space mean speed, we will take a space, x distance, for example 1 kilometer. In that, you have to find out the space mean speed of a vehicle, for example 10 a.m. to 12 p.m. Okay, calculate all vehicle speed and find out space mean speed is equal to n divided by t1 divided by l. The length is constant, okay, plus t2 divided by l. What is t1 by l? It's a velocity, right? Velocity of all vehicle you have to measure. Okay, from that you can able to find out the time, or you have to find out the time. This is x, you know, right? Let us consider this is x is equal to l. L is constant. So you have to measure the speed, or you have to measure the time while reaching from this point to this point. Once you know the time, length is constant, right? Length divided by time, you will get a velocity, right? Velocity of that vehicle for this stretch plus etc. Okay, so this is the way to do space mean speed. And this formula further uh, modified as, so please refer here, Vs is equal to n divided by, what is t1 by l1? Sorry, what is l1 by t? Take this t1 numerator of this l1, that 1 by v1, 1 by v2 plus etc. So this is the answer. Okay, keep these two formula in your upcoming examination in your mind. Okay, so these are the important points. The next one is the objective of traction compression test is to determine the shear strength of soil under lateral compression. So that is important, under lateral confinement. So this is the answer. How this the answer? You know, the test procedure of traction test. The traction test specimen is prepared like that. It's like a cylinder. Then the first thing is we will give a confining pressure over the soil sample. This is the sigma 3. We will give the first stage is we will give the confining pressure. Once we finish this, by keeping this confining pressure is constant, that means this is sigma 3, this is sigma 3, this is sigma 3, this is sigma 3. By keeping this sigma 3 is constant, after that we will apply a direct load, that is a deviator stress. Okay, therefore here sigma 1 is equal to sigma d plus sigma 3 is equal to major principal stress. Sigma 3 is equal to minor principal stress. Minor principal stress, or we can say is a confining pressure, or we can say is confining pressure. Understood? So the objective of traction compression test is to determine the shear strength of soil under lateral confinement. Here lateral confinement is mean what? It's a lateral pressure due to water. That is sigma 3. Sigma 3 means minor principal stress. This minor principal stress is the lateral confining pressure. Okay. So the answer for this question is C. So our next question. The least count of a standard vernier theodolite is a factual data. Answer for this question is 20. Okay. The least count of standard vernier theodolite. So answer for this question is 20 seconds. Keep in your mind. Okay.